Start this one. All right, here we go again. Oh, my back. Okay. I can make it. All right, here we go. I got to break down the 15, okay? So I want to think, what goes into 15? 3 and 5, 5 and 1. So there are no pairs, right? So that stays the square root of 15. But then I have the 80. So I want to break that down. Not make it all the way over here because we're doing that exponent, which is the simplifying or definition of prime factorization, PF. Okay, so we're going to break down the 80. 2 goes into 80, 40 times, 2 goes into 40, 20 times, 2 goes into 20, 10 times, 2 goes into 10, 5 times, 5 goes into 10 once, right? And so let's look at how many pairs there are. Here's a pair of 2's, and here's a pair of 2's. So that means we have 2 times 2 times the square root of 5. And 2 times 2 is 4, right? So you really have 4 square roots of 5 times 4, because there's a 4 out inside of 80, right? So what's 4 times 4? 16 square roots of 5. Okay? And so here was all this definition of prime factorization. Okay? And so after that, we can't have a radical in the bottom. But what's really cool about radicals, if I have a radical, say I have radical 3 and a radical 2, that's the same as just saying 3 times 2, right? Which is 6. Okay? And the cool part about that is when I have a radical 15 over a radical 5, right? I really have the square root of 15 over 5. Does 5 go into 15? Yes. So I can multiply what's in the box with what's in the box, is what I say. And I can divide what's in the box by what's in the box. As long as the box is the same box. As long as they're both square roots. And one isn't a cube root and the other one's a square root. Does that make sense? So then how 5 goes into 15 3 times, right? So we're left with the square root of 3 over 16. So that's all we did. Is we said, hey, what goes into 5 and 15? 5. How many times? 3 and 1. But the square root of 1 is just 1, so we don't need to write that. Okay? And that is simplifying. Okay? So again, what goes into 10 and 4? What goes into 10 and 4? 2. 2! So I can just pull that out right away. 2 goes into 10 5 times. 2 goes into 4 2 times, right? Now it looks done, doesn't it? Why is it not done? Help me out. Kailani.
What?
Why is this not done? What's the rule about a square root in the bottom? We can't have it. So, we have to get rid of the square root in the bottom. So to get rid of the square root in the bottom, you multiply it by the same square root. But what you do to the bottom, you have to do to the top. We're just basically multiplying it by 1, right? But we're making it look different. Okay? And so, we had this given, and then we did the green, which was the opposite of distribution. We're going to call it simplification, right? Reducing, right? And then now we are going to simplify it again. Okay? But this simplifying is using a radical. So it's radical simplification. What? Okay? We can do it like this. What? Radical simplifying. Okay? And so 2 times 2 is 4. The square root of 4 is 2, right? And so that's what's happening is we're getting, not 4, sorry, 2. We're getting rid of the square root. Now what's 2 times 5? 10, right? There's no pairs there, so we're still left with that square root of 10 over 2. Okay? All right.
Wait. So we
just multiply it by the radical that's in the bottom, like here. Now I can't, the 4/3 is reduced all the way, right? And 7 doesn't go into 5, 5 doesn't go into 7. But we can't have that 5, so we have to multiply by 5 over 5, right?
You didn't even have me count.
And then what is 5 times 7?
I did 35.
Right? And what is 5 times 5?
25.
And then we reduce that, right, to back down to 5, right? Square root of 25 is 5. And then what's 5 times 3? 15. And if there can be reduced, then we reduce it. If not, then we're done. So again, we had given, and then we had the radical simplification. Now this one, we got 2. What goes into 6 and 4? 2, right? How many times does 2 go into 6? 3 times. How many times does 2 go into 2? Or 2 goes into 4? 2 times. Okay? So we reduce that. But we still have a radical in the bottom. So how do we get rid of that radical? So, given radical simplification. Oh, whoops. No, we just simplified. Sorry. Now we're going to do radical simplification. Right? And radical simplification means I'm going to multiply the bottom and the top by the radical that's in the bottom. And what that does is it gives me the pair. So I have 2 times 5 here. So I got 3 and I have 2 times 5 up there, which is 3 square roots of 10 over 10. And then if I can reduce, I do, but I can't. So I won't, and I'm done.
Okay.
Question. I see a question on that head.
Yeah.
No, I need it in the video so people can hear it. I'll re-say it. You can be quiet about it. It's a question. I won't say your name, so nobody knows who you are.
So, Brandon, you have a question?
We won't say that. It's Brandon that has a question. Go on. What's the question? Every question is a good question.
Would I put B5 on the bottom?
Which one?
15, 7.
On 7?
Brandon Moran has retracted his question.
So,
Oh, okay.
it is 5, but 5 times 3 is 15.
Oh, right.
Yep.
I'm probably skipping some steps because we are geometry, but maybe I should show all the steps. Like this one turned out to be 4 of the square root of 7 times 5 and 3 times 5. And then we were able to get 4 square roots of 35 over 15. So that's how we got there.
Wow. Okay.
Better?
And you still recording?
Yep.
Long video for nothing.
Oh, it's